Hey guys, it's Mrs. Spears. Today I'm doing lesson 12.6, metric units of length. Before I get into that, the page before is also in your packet. It's the mid-chapter checkpoint on page 671. This is a great review of all lessons before this. It's got customary units and benchmark units and line plots in it. So do this page with someone at home and have them look it over for you. You may use the other pages in the other sections to refresh your memory if you need to. But this is a great review. This and the back is some word problems about the same thing. That's all a great review about what we've done already so far in the other videos. But today we're doing metric units of length. Welcome to this big, beautiful metric system. Most of the world actually uses the metric system. I think you'll see why. It's got an awesomeness to it that I think a lot of the world recognizes, but most of the United States uses the customary system that we've already done. You do see the metric system from time to time in the United States. Mostly you use it in scientific measurements. Scientists use the metric system to record their data with. So whatever they're measuring in, they use metric units instead of customary units. I don't know if you talked about this in science or not, but it goes back to how scientists all use the same type of system all over the world. So that if, say a scientist in China was studying something, their numbers would be the same as somebody here in America because the science community is using the metric system. So, like I said, if your family is from another country, then they're probably pretty familiar with the metric system because most other countries use it everywhere. We are one of the only countries that does not. But there is a really awesomeness, like I said, to the metric system. I like it a lot. I think it's cool. I wish the United States used it more often. Because the one bummer I think about the customary system, let me show you something. Let's see what you think. You can form your own opinions, whether it's one you like better. Let me show you something. With the customary system, what's difficult about the customary system is you have to remember how many of each thing is inside another thing. So with this one, in order to go from inches to feet, you have to remember there are 12 inches in a foot. From feet to yards, you have to remember that there are only 3 feet in a yard. Down here, there's 16 ounces in a pound, but 2,000 pounds in a ton. So the differences between each of these is not even. Same thing with volume. The differences are not even in that as well. But the beautiful part about the metric system is that they're all evenly distributed. And I'll show you what that means here in a minute. But it reminds me a lot of our place value system that we understand. So, welcome to the floor of my office. I usually have you at my desk with the book, but for now I have you on the floor. So as I wanted to show you, I don't have any meter sticks here at home. Hashtag quarantine, hashtag can't go to school, hashtag don't want to go to the store to find one. So I made one myself today out of just strips of paper. So I have this little tiny strip of paper. Do you see how tiny that is? Do you see how tiny it is? Maybe you can't because it's kind of fuzzy. But the width on that, how wide that is, that little bit across, that's how big a millimeter is. So that's the smallest unit is millimeters. The next size up is the centimeter. Notice the word meter is in both of those words. It's just the end word. I'll get to that here in a second. There are 10 millimeters, in a centimeter. So if I were to cut out 10 of these guys, put them end to end and tape them together, they would equal 1 centimeter. The next size up is the decimeter. This is equal to 10 of these guys. So 1 centimeter is 1/10 of 1 decimeter. If I were to cut out 10 centimeters and stick them together with tape, it would be the same length as this 1 centimeter. So if there's 10 of these guys in here, and 10 of these guys in here, 10, 10, 10, 10, 10, 10, 10, all the way down 10 times means that there is 100 of these guys in a decimeter. Again, that's because there's 10 centimeters in here. 1 centimeter times 10 milliliters, because 10 millimeters fits in a centimeter. So 10 times 10 is 100. So there are 100 of these guys in here. Then we've got 1 meter. Meter is the central unit to this. Meter is just the metric word for length, I'm guessing. I don't know if that's really true. There's no such thing as the metric word for something, but I'm guessing it's a word that means length of some kind. But basically, whenever you're measuring length using the metric system, you are using some form of meter. Whether it's 1 whole meter, a decimeter, a centimeter, or a millimeter, it's some kind of meter. And that meter word represents length. So within 1 meter, there are 10 of these decimeters. So literally to make this 1 meter strip, I cut out 10 decimeters and I taped them together. The black lines are where you can see where one starts and one ends all the way up. So I have 10 of those on here. So this is why I think the metric system is pretty cool. I think it's pretty cool because it's just 10 times the one before it. So a meter is 10 times bigger than the size before it, which is a decimeter. A decimeter is 10 times the size of the unit before it, which is a centimeter. A centimeter is 10 times bigger than the millimeter. So each one is times 10, which is pretty cool because we're used to that being, in our place value system. So like if I gave you the number 1, let's say I gave you a 1, I told you to multiply it by 10, you would get a 10. You get a 1 in your tens place now. That's your next place value up. If I told you to take 10 and multiply it by 10, you would get a 1 in your hundreds place, which would be 10 times up from that. And then if I were to tell you to do 10 times bigger than that, it would be 1,000. So there's actually 1,000 millimeters in 1 meter because you're doing 10 times 10. Well, I guess, sorry, it's just 1 times 10. Never mind. Oh, no, where'd it go? There it is. So I got 1 times 10 to get here, 10 times 10 to get here, which means there are 100. 10 times 10 is 100. So there's 100 millimeters inside 1 decimeter. And then, so 10 times 10 times 10 is 1,000, which means there are 1,000 millimeters in an entire meter. Going from here to here to here would be 10 times 10, which is 100. So there's 100 centimeters in a meter. And going from here to here is 10 decimeters times 10 spots, which is, not 10 decimeters. 1 decimeter times 10 would get you the 10 decimeters in the 1 meter. Sorry if that's a little confusing. What's cool about your book is when you're doing with this, they give you all of those in the chart. You don't have to have those memorized. Achievement testing, you don't have to have them memorized. They give you all that information. I just wanted to show you where all that came from. And you can actually see it if you go back to your book and you go to this page 675. They've got all that information I just told you in this box. So you don't actually have to, when you're doing all the conversions, you don't have to come up with those numbers on your own. They give them to you. Okay, so let's answer these questions using the strips. Let's see here. 1 meter is blank times as long as 1 decimeter. So here's my whole meter stick. 10 decimeters make up the 1 whole meter stick. So 1 meter is 10 times as long as 1 decimeter because I needed 10 decimeters to make up 1 whole meter. 1 decimeter is blank times as long as 1 centimeter. So decimeters to centimeters. I need 10 of these centimeters to make up 1 decimeter. So that's also 10 times bigger. And then 1 centimeter is 10 times as long as 1 millimeter because I need 10 millimeters to make up 1 centimeter. So describe the patterns that you see, each unit bigger. So millimeters are your smallest ones, centimeters your next size, decimeters your next size, meters your next size. Each value is 10 times bigger than the one before it. So that's the pattern. I'm going to say each increasing unit, so as the units get bigger, is 10 times larger than the unit before. So that's the cool thing about the metric system. I think that's, like I said, why the world uses it more than the other system, is because it's just in increments of 10. Makes it a little easier to keep track than trying to keep track of like 16 or 2000 or, you know, 12 or something like that. It's just, it's consistent. Compare the size of 1 meter to the size of 1 centimeter. Use your meter stick to help. So we've got 1 centimeter here, or 1 meter, sorry, compared to, well, I'll leave these here so you can see them. So this question is comparing the meter, the big one, to the centimeter. Because there is 10 centimeters in a decimeter, I need 10 of these to make one of these. I need 10 of these to make the big meter. Like I said earlier, I would do 10 times 10, which means that there are 100 centimeters in a meter. Because like I said, I got to go from 10 times 10, 10 to 10. Or 1 times 10 times 10, but you know what I mean. So, I'm going to say 1 meter equals 100 centimeters. So when I'm using the metric system, my brain actually goes from one unit to the next. So if I was trying to figure out how many centimeters were in a meter, my brain would be like, okay, Mrs. Spears, your brain says that 1 centimeter, there's 10 of those in a decimeter, and there's 10 decimeters in a meter, which means 10 times 10 is 100. And that's how I figure it out. But like I said, your book is really nice, and they actually give you all of that information right here. So you can use this chart as much as you want. Because even when you are achievement testing, they will give you charts like this. So, I'm going to take you back up to the, oh, actually, hang on. We go to page 674. Go to that page for me real quick. I'll do these last few questions with you with the strips. And then I'll take you back up to the desk so we can just do it with just math. Compare the size of 1 meter to the size of 1 millimeter. Use your meter stick to help. So this is the same idea. We've got one of these little tiny millimeters. There's 10 in a centimeter, so that's 1 times 10. 10 centimeters in a decimeter, so that would be 1 times 10 times 10, that's 100. And then 10 decimeters in a meter, so that would be 1 times 10, which is 10, times 10 is 100, times 10 again is 1,000. So there are 1,000 millimeters in a meter. So I've got 1 meter equals 1,000 millimeters. What operation could you use to find how many centimeters are in 3 meters? There's different ways you could have done this. There is, you can figure out that 1 meter equals 100 centimeters. So 3 meters is equal to 3 times 100, which equals 300 centimeters. Oops, sorry. You could have used some addition. You could use multiplication. Multiplication is quicker, but it's up to you how you could have done that one. All right, transitioning back to desk. Field trip over. Give me a second. Okay. All right, you can use different metric units to describe the same length. For example, you can measure the length of a book as 3 decimeters or as 30 centimeters. Since the metric system is based on the number 10, decimals or fractions can be used to describe metric lengths. as equivalent units. So I'm not really going to go over all of these with you because the intention for these questions down here are for you to use fractions and decimals to describe what fraction of a meter is each of these units. Technically, this is a chapter that we weren't really supposed to learn until towards the end of the year, but I figured it was the chapter that your parents would be most helpful for you on, because it's something that they use, you know, when they're measuring stuff. So I haven't taught you how to do the decimal parts of this yet. That was what we were supposed to learn after we finished multiplying fractions. So when we get back to school, that's what we're going to learn. So stay tuned for this stuff right here. I'm not getting into this today because, like I said, I haven't taught you the decimal ideas behind it just yet. I can do these ones with you because we can figure these ones out pretty easy. But stay tuned for these guys later on. So 1 meter is 10 decimeters, so each decimeter is 1/10. Or the decimal form is 0.10 of a meter. Like I said, that's a decimal part we have not learned yet. So I'm not really getting into this too much because we haven't gotten that far yet. We'll come back around to it once we learn the decimal stuff. Each centimeter is, oh, it's here, 100 centimeters in a meter. So each centimeter is 1/100th of a centimeter, or 0.01 of a meter. So yeah, we'll get into that later. Stay tuned. Coming over here to page 675. All right, so we've got 2 meters equals centimeters. So we're going from meters to centimeters. So meters to 1 meter is 100 centimeters. So I'm going to multiply 2 times 100, because there's 100 in the first meter, 100 in the second meter, because there's 2 meters. So 2 times 100 equals 200. So there are 200 centimeters in 2 meters. 3 centimeters to millimeters. So we're going to come over here. Centimeters to millimeters. There's 10 millimeters in a centimeter, 10 of those little tiny ones in the next tiny one. So I'm going to multiply this number by 10. So as I got centimeters, 10 is my conversion. So I'm going to take 3 centimeters times 10 millimeters, and that equals 30 millimeters. 5 decimeters equals centimeters, so 1 decimeter is 10 centimeters, so I'm going to multiply by 10. 5 decimeters times 10 centimeters, because there's 10 in each of those, equals 50 centimeters. All right, I'm going to do these two, and then I'm going to, I'll do the first two, and then you can do the next two, and then we'll check it. So I've got 4 meters and 40 decimeters. These are having you compare. Like I've said in other videos, you cannot compare unless they're in the same unit. Yes, they're all meters, but that doesn't really help us very much. We just know they're all measuring length. This is in decimeters and this is in meters. Meters are much bigger than decimeters. So we have to convert all of these to the same unit. And as in other videos, I would say go from this biggest unit to the smallest unit. So out of these two, meters and decimeters, decimeters is the smallest. So I'm going to turn this into decimeters. So meters to decimeters, there's 10 in there. So I'm going to multiply. 4 times 10, which equals 40. So now I've got 40 decimeters against 40 decimeters. So that's the same. Those are equal to each other. So I have to have 4 meter sticks is the same thing as taking 40 decimeter sticks and lining them up. You're going to equal the same length. Over here we got centimeters to millimeters. Millimeters is the smallest, so I'm going to turn the centimeters into the smallest unit. So let's see here. Centimeters and millimeters. There's 10 millimeters in a centimeter. So I'm going to multiply by 10. So now we have 50 millimeters against 5 millimeters. That means that this one is bigger. Again, these look like they should be equal. 5 and 5, well, that's equal. No, it's not. The unit is the most important part, so you have to make sure you have the same units against the same units. So I'm going to have you pause the video right here so you can try these two. Remember, convert your biggest unit to the other unit, and then compare. So pause here. All right, so here's your answers. So we're going from decimeters to centimeters. Centimeters are smaller. Those are the cube ones. So decimeters and centimeters. Got 10 in there. So I'm going to do 6 times 10 to give me 60 centimeters. 60 centimeters versus 65 centimeters. 65 is bigger. And meters to millimeters, that's a big jump. That's going from the little tiny guys to the big giant ones. So 1 meter is 1,000 millimeters. So I'm going to multiply by 1,000. 7 times 1,000. Remember, just multiply the numbers together and then stick your zeros on. 7 times 1 is 7 with 3 zeros. So it's 7,000 millimeters versus 700 millimeters. That one's much bigger. These ones, again, have you practice like the decimal things that were down here that we're not really going to do. I'll just do some of these with the fraction part of you with you since we've done fractions before. I'm going to cross out these boxes because, like I said, we'll come back to those someday once we've learned the decimal parts of it, once we go back to school. 65 centimeters. Turn centimeters into meters, which that would be... Describe the length in meters. Yeah, okay. That would actually be smaller. So, because 1 meter is 100 centimeters, well, that's smaller than 100. So I can't do a whole number as my answer. This is why we have to turn this into a fraction. So 65 centimeters, because there are 100 centimeters in a meter, 65 of them would just be 65 hundredths. Because it takes 100 centimeters to make up 1 meter. So I don't have enough to make 100, so I have to write it as a fraction because it's not a whole meter yet. It's just part of a meter. Same thing with this one down here. It takes 10 decimeters to make 1 meter. If you look over here, 10 decimeters to 1 meter. I can't multiply because I'm not going from something bigger to smaller. I'm going from something smaller to bigger in these problems. I need 10 of these guys to make 1 whole meter, and I can't do that. I only have 9. I only have 9 of the 10. Same thing with this one. This one's similar to this one. I need 100 centimeters to make a meter. Same thing here. I still need 100 centimeters to make a meter. I only have 47. So I can do 47 out of the 100 that I need. And same thing here. I need 10 decimeters to make a 1 meter. So I only have 2 of the 10 that I need. Like, so we will get back into this when we come back to school. So don't worry about it if you don't quite understand this part. We'll get back to this later. What I really want you to get out of this lesson is how to do this stuff up here. How to use these charts to multiply to be able to compare the units. Much like you did with the customary units. But this time it's got the metric system. All right. A new building is 25 meters tall. How many decimeters tall is the building? So with this one, it's going to be 25 meters equals blank. Oops. Decimeters. Okay. That was kind of weird. So meters to decimeters, going up here using the chart. Meters to decimeters, there's 10 decimeters in a meter. So I'm going to do, oops, 25 times 10. Again, you don't even need to go over to the side and multiply this out. Just multiply your numbers and then put your 0 on. 25 times 1 is 25 with 1 0. So that's 250 decimeters. That's where that multiplication trick comes in handy once again. Okay, I'm super excited about this problem because I love to knit. And so that's what this one's about. Alexis is knitting a blanket 2 meters long. Every 2 decimeters, she changes the color of the yarn to make stripes. How many stripes will the blanket have? So this one, in order for me to solve it, I had to draw a picture. So if her blanket is 2 meters long, so I'm going to draw a picture over here to the side. So there's her blanket. It's 1 meter and 2 meters long. So I'm going to put 2 meters off to the side. Every 2 decimeters, she changes the color of the yarn. Well, I know that 1 meter is divided into 10 decimeters. So I'm going to... Oh, not too even. Mrs. Spears, you know better. Oh, you can't even see my picture right now, can you? Whoops, sorry. It's not super important that these are even in this picture, so it's just a representation. So I'm taking, oh geez, I can't even show you, sorry. I'm taking each meter and dividing it into 10 pieces because there's 10 decimeters in a meter. This is where my new tripod would have come in handy. Okay, so same thing down here. I'm going to take this and divide it into 10 pieces as well. All right, not too bad. Could be better, but not too bad. It says every 2 decimeters, she changes the color of the yarn to make stripes. So, looks like she's got, these 2 are going to be one color. These 2 are going to be another color, because she's skipping every 2. These 2 are going to be the first color. Skip 2, color 2, skip 2, color 2, skip 2, color 2, skip 2. So how many stripes is she going to have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She's going to have 10 stripes. And again, I just did it. I just drew a picture for this one. You could have done it as, she's got, you know, converted them all. You could have taken this, converted it into meters into decimeters, and then divided that way. This you could just solve also with a simple picture. So that's up to you how you want to do that one. I'm not going to do these problems with you. You can do these ones for challenge if you want to. This one uses some decimals in it too that we haven't gotten to yet, as well as this one. If you want to try this one, here's the answers to it. Again, we have not learned this yet because we skipped that chapter to do this one. We'll come back to it eventually, but there's your answers for that if you want to answer it. This one out here is like a totally open-ended question. You could make a line plot if you wanted to show, you know, how many, what the average measurements were. I guess you couldn't really use a line plot. That's a bummer. But, so that's an option with that too. But you could make your own problem or do whatever you want with this. This was pretty open-ended. It's up to you how you want to do it. But I'm not grading that one. Same thing with that one. So, like I said, this page, if you don't do this page, I'm not going to be upset because this is all stuff, this stuff we haven't learned yet up here, and this is kind of just for funsies down here. So, but yeah, if you have any questions, just leave me a comment. I know this video was kind of funky because I seemed a little all over the place. But if you have any questions, just let me know and I will clarify in the comments. Thanks, guys. I will see you later. Bye.